Yeah, good afternoon, students. Yesterday we did reduction formula, right? 7 marks, and with that, 7 marks integration has been done. And nowadays, partial fractions very rarely is asking. Okay, partial fractions integrations won't be tough, right? So just you can have a look so that just you can go through it. You can also understand because the integrations will be very simple. And anyway, partial fractions, partial fraction, you know how to do it in maths 2A. So no. So according to that, so your partial fraction, you can do it easily. Excuse me. So your partial fraction, you can do it easily. That is not a problem. But most important questions in exam point of view, that is your models, that is types, different types of integrations, method 1, method 2, method 3, method 4, and reduction formula also. We finished. So no need to have any problem there. Now let us do 7 marks of. So your parabola long answers has been done. Parabola long answers has been done. Your parabola long answers has been done. Your parabola long answers has been done. Integrations 2 long answers has been done. Circles 2 long answers has been done. Is it clear? So 5 it is done. Now what you are going to do is these 5 you have to write it properly so that you will not have any confusion. And what I suggest you is instead of going for definite integrals and differential equations, better you do parabola 1 long answer, which your long answers has been done. Parabola long answers, circles 2 long answers, circles 2 long answers, and indefinite integrals 2 long answers. Is it clear? Indefinite integrals 2 long answers. Okay, right. So let us do few definite integral long answers, which are important, and let us hope you can do it from here also. Okay, right. First one, integration of 0 to pi by 4, very, very important one. Sin x plus cos x divided by 9 plus 16 sin 2x dx. 0 to pi by 4, sin x plus cos x divided by 9 plus 16 sin 2x dx. Right? See the solution. So 0 to pi by 4, sin x plus cos x by 9 plus 16 sin 2x dx. Now put sin x minus cos x equal to t. This is very important substitution. Is it clear? Now differentiate with respect to x. Sin x derivative is cos x. Cos x is minus into minus sin x dt by dx. Then dx equal to dt by cos x plus sin x. The dx is nothing but dt by cos x plus sin x. Right. Change the limits also. That is upper limit. What is your upper limit? Your upper limit x is pi by 4. So sin pi by 4 minus cos pi by 4 is t. So 1 by root 2 minus 1 by root 2. Your t is 0. Change your lower limit also. Now what is your lower limit? X is 0. That is sine 0 minus cos 0 equal to t. When t equal to 0 minus 1, that is minus 1. Again, sin x minus cos x, you take this also separately. Sin x minus cos x equal to t, squaring on both sides. These three things you have to do compulsory. First, what is the substitution you are going to take? The substitution what you are going to take is sin x minus cos x equal to t. Very important substitution. Once you take sin x minus cos x equal to t, differentiate with respect to x, then cos x plus sin x is equal to dt by dx. Your dx is nothing but dt by, then change your limits. Then again take sin x squaring on both sides. That is sin x minus cos x whole square equal to t square. So sin square x plus cos square x minus 2 sin x cos x equal to t square. 1 minus sin 2x. Then sin 2x is 1 minus t square. See, sin 2x also in terms of 1 minus t square you got. Okay. Now replace everything. What is that everything? Instead of dx, listen. Instead of dx, you are going to replace this. Instead of the limits, these limits, you are going to replace with this and this. And instead of sin 2x, you are going to replace 1 minus t square. So these are the changes. Is it clear? Now next board I am going to do that only. So integration of minus 1 to 0, correct? Sin x plus cos x right now as it is, divided by 9 plus 16 into this is 1 minus t square. Correct now? And what is dx? dt by sin x plus cos x. Now this gets cancelled, limits has been changed. So that is minus 1 to 0, 1 by 9 plus 16 minus 16 t square dt. Minus 1 to 0, 1 by 25 minus 16 square dt. Take 16 outside. Take 1 by 16 outside. Integration of this becomes 1 by 25 by 16 minus t square dt minus 1 to 0. Is it clear? I took 16 common. 16 outside. Then 1 by 16 minus 1 to 0, 1 by 25 by 16 minus t square dt. That is 1 by 16 minus 1 to 0. This is 1 by 5 by 4 whole square minus t square dt. Now, how it look like? What is that formula I'm going to use? Integration of 1 by a square minus x square dx is 1 by 2a log of a plus x by a minus x. 1 by 2a log of a plus x by a minus x. Is it clear? So 1 by 16 into 1 by 2a 5 by 4. And what is that? Log of 5 by 4 plus t by 5 by 4 minus t. Now apply your limits, minus 1 to 0. That is only no. Your definite integrals. You have to apply the limits. Your definite integral, you are going to apply the limits. Is it clear? So this is 1 by 16. 2 ones are 2 twos are, 2 ones are 2 eights are. So total how much I am getting? 1 by 40. 8 5s are 40, right? Into log of 5 plus 4t by 5 minus 4t. What are your limits? Minus 1 to 0. That is 1 by 40. Apply your limits. Log upper limit 5 plus 4 into 0 by 5 minus 4 into 0, correct? Minus minus log of 5 plus 4 into minus 1. 5 minus 4 into minus 1. This is your 1 by 40 upper limit minus lower limit. Log of 5 plus 40 by 5 minus 40. Instead of t, you put 0, that is upper limit minus. Instead of t, you put minus 1, that is your lower limit. Is it clear? So that I am going to get it as 1 by 40 into log, what I am going to get there? 5 by 4 by 5 by 4. Correct, no? Log of, see here, 5. Okay, log of 5 by 5 you take it as. Log of that is log of 5 by 5 minus log of 1 by 5 plus 4 is 9. So 1 by 40 log 5 by 5 is 1. Log this is 9 inverse. So 1 by 40 log 1 is 0 minus inverse, you bring it according to log properties. Log x power a is a log x. This a will come as coefficient. So in this case, your minus 1 log 9, I will write it as now 3 square. So 1 by 40 minus into minus plus log 3 square. So 1 by 40, again according to logarithmic property, 2 log 3, 2 ones are 220 times. 1 by 20 log 3. 1 by 20 log 3. Very, very important. Very, very important sum. Is it clear? Next, most important 7 mark. Again, indefinite integrals. Evaluate integration of 0 to 1 log of 1 plus x by 1 plus x square dx. Evaluate 0 to 1 log of 1 plus x by 1 plus x square dx. Okay. Now, most important substitution. 0 to 1 log of 1 plus x by 1 plus x square dx. Now put x equal to tan theta. This is most important substitution you are going to. Now differentiate with respect to x. X derivative is 1. Tan theta derivative secant square theta. And theta derivative is d theta by dx. Means dx is equal to secant square theta d theta. You keep this part there itself. Is it clear? Next, change the limits also. So lower limit. What is the lower limit? X is 0. Means 0 equal to tan theta. Then tan theta is equal to 0 is tan 0 only. Then theta equal to 0 degrees. Next, upper limit. Next, upper limit. Is it clear? Now, what is your upper limit? X equal to 1. Means 1 equal to tan theta. Then tan theta equal to 1, I can write it as tan pi by 4. Theta is equal to pi by 4. See, I changed the limits also. Now go back and substitute everything in integration. Go back and substitute everything in integration. Is it clear? Go back and substitute everything in integration. So what happens? Integration of 0 is 0 only. Your upper limit is pi by 4. Next, log of 1 plus X I took it as tan theta by 1 plus tan square theta. 1 plus x square, no? And dx is what? Secant square theta d theta. Now 0 to pi by 4 log of 1 plus tan theta by 1 plus tan square theta is secant square theta. Here also secant square theta d theta. Secant square gets cancelled. Now let us take it as I equal to 0 to pi by 4 log of 1 plus tan theta d theta. Is it clear? Now this one you are going to take it as I equal to. So here you are going to substitute, put x equal to tan theta. You are going to substitute, put x equal to tan theta. Then differentiate with respect to x. Important substitution, put x equal to tan theta. Then differentiate with respect to x. 1 is equal to secant square theta d theta by dx. Dx is nothing but secant square theta d theta. Change your limits. Lower limit x is 0. Upper limit x is equal to 1. One is equal to tan theta. One is equal to tan theta. Then tan theta equal to tan pi by 4. Theta is again pi by 4. Then 0 to pi by 4, replace everything. Then at last what you will get is 0 to pi by 4 log of 1 plus tan theta d theta. 0 to pi by 4. Okay. This I am going to take it as 1. This I am going to take it as 1. So I equal to 0 to pi by 4 log of 1 plus tan theta d theta. This I will take it as 1. The most important property what we are going to use? The most important property is 0 to a f of x dx is 0 to a f of a minus x dx. 0 to a f of x dx is so 0 to a f of x dx is equal to 0 to a f of a minus x dx. This is the property I am going to use, right? So I equal to 0 to pi by 4 log of 1 plus, instead of x you have to put a minus x. What is a in this case? Your a in this case is, this is your a, that is 0 to pi by 4. Is it clear? So right. So now 1 plus tan of pi by 4 minus theta, f of a minus x, okay? Pi by 4 minus theta is d theta, okay? Now I is equal to 0 to pi by 4 log of 1 plus tan of a minus b. That is tan pi by 4 plus theta formula. Tan pi by 4 plus theta, 1 plus tan theta by 1 minus theta. And tan pi by 4 minus theta, it is 1 minus tan theta by 1 plus tan theta. 1 minus tan theta by 1 plus tan theta. So in this case it is tan pi by 4 minus theta. 1 minus tan theta by 1 plus tan theta d theta. So I is equal to 0 to pi by 4. I applied this property, okay? I applied this property 0 to a f of x dx is 0 to a f of a minus, means wherever you find a, wherever you find x, you replace it with a minus x. So in this case, your x is like theta variable. So instead of theta, you replace pi by 4. That only I did. Now take LCM. Log of 1 plus tan theta plus 1 minus tan theta by 1 plus tan theta into d theta. Now, that is I is equal to 0 to pi by 4 log of, now tan theta gets cancelled. 1 plus 1 is 2 by 1 plus tan theta d theta. This I will put it as 2. Now add 1 and 2. That is I plus I, 2i. According to integrations, according to definite integrals property, you can add both the integrations if they are having the same limits. So 0 to pi by 4, it is log of 1. What is 1? 1 plus tan theta. Plus what is 2? Log of 2 by 1 plus theta. 2 by 1 plus tan theta. Right? Next board will continue. That is 2i is equal to 0 to pi by 4 log of 1 plus tan theta plus log of 2 by 1 plus tan theta d theta. But according to logarithmic properties, log m plus log n is log m into n. So in this case, I can write it as 2i is equal to 0 to pi by 4 log of 1 plus tan theta into 2 by 1 plus tan theta d theta. Now these two gets cancelled. 2i is equal to 0 to pi by 4 log 2 d theta is left out. So 2i is equal to log 2 outside 0 to pi by 4 1 d theta. So 2i is equal to log 2 as it is. Integration of 1 means theta with respect to d theta. It's 0 to pi by 4. So 2i equal to log 2 into upper limit minus lower limit. That is I equal to, or 2i equal to pi by 4 log 2. Then I equal to pi by 8 log 2. So very, very important sum. It is pi by 8 log 2. Let us hope so. You get one of your sum. Is it clear? Already parabola long answer has been done. Circles 2, integrations 2. This should be our strength, frankly speaking. Is it clear? I hope you are Okay, let us go for next one. Integration of 0 to pi, evaluate x sin x by 1 plus sin x dx. Evaluate 0 to pi, x sin x by 1 plus sin x dx. Solution, I is equal to 0 to pi, x sin x by 1 plus sin x dx. We will put this as one equation. Again, the same property. What is that property? 0 to a f of x dx. I will write it as 0 to a f of a minus x dx. 0 to a f of x dx is equal to 0 to a f of a minus x dx. Now I is equal to 0 to pi. In this case, your a is nothing but pi. 0 to a, 0 to a, your a is pi. So pi minus x sine of pi minus x by 1 plus sine of pi minus x dx. Little bit simplification of this. 0 to pi. This pi minus x will be as it is. Sine 180 minus theta is sine theta and sine theta dx. This I will put it as 2. Now add 1 and 2. Add 1 and 2. Add 1 and 2 means what I will get? I plus I, 2i. 0 to pi, x sin x by 1 plus sin x plus pi minus x sin x by 1 plus sin x. Is it clear? So 2i is equal to under one integration and your LCM is same. So 1 plus sin x. Now x sin x plus pi sin x minus x sin x. Now x sin x gets cancelled. Is it clear? Now what is left out? That pi I will write it outside. That is 2i is equal to pi, write it outside. Sin x by 1 plus sin x is left out. Correct now? Right outside you got so sin x by 1 plus sin x. Sin x by 1 plus sin x. Now I am going to see this manipulation. 2i is equal to pi sin x, add plus 1 and subtract 1. Why we are adding and subtracting 1 only? Based on what the number I am having here in denominator. Is it clear? So 2i is equal to pi, that is sin x plus 1 by 1 plus sin x minus 1 by 1 plus sin x dx. And 2i is equal to pi. This gets cancelled, that is 1 minus 1 by 1 plus sin x dx. So 2i is equal to, what are your limits actually? 0 to pi, right? So your limits are still 0 to pi only. The limits are 0 to pi. Now separate your limits and integration simultaneously. 1 dx minus 0 to pi. Here also you get pi 1 by 1 plus sin x dx. Separate your integration along with limits, right? So that is pi 0 to pi 1 dx minus pi 0 to pi 1 by 1 plus sin x dx. So 2i is equal to this pi, integration of 1 is x, this is 0 to pi, this is done. Minus pi, this is 0 to pi. Now 1 by 1 plus sin x integration, I will rationalize, divided by 1 plus, rationalize with the denominator with opposite sign. So 2i is equal to pi. This is pi minus 0. Upper limit minus lower limit is 0 to pi. 1 minus sin x pi. This is 1 minus sin square x. This is pi square minus 0 to pi. 1 by cos square x minus sin x by cos square x dx. So 1 minus sin square x is cos square x. Now 2i is equal to pi square minus pi, integration of 0 to pi, secant square x minus sin by cos, and this is secant x dx. Now do the complete integration. Pi square minus pi, open the back. Integration of secant square x is tan x, and this is secant x, and 0 to pi. Right? So I'll make the conclusion in next board. So 2i is equal to pi in, 2i is equal to, what is that? Here I get pi square minus pi into pi square pi square minus pi into complete upper limit. What is that? What was your complete upper limit? Tan x, tan pi minus secant pi. Tan pi minus secant pi minus tan 0 minus secant 0. So 2i equal to pi square minus pi. Tan pi is 0 minus of minus 1. Secant pi is minus 1. Minus 0 minus of minus 1. That is 2i equal to pi square minus pi into this becomes, sorry, secant 0 is 0, secant 0 is plus 1. Secant pi is minus 1. Secant 0 is plus 1. Okay. So minus into minus plus 1. That is 2i equal to pi square minus 2i. I equal to pi square by 2, pi square by 2 minus pi. Very, very important sums. All these are, is it clear? Okay. Very, very important sum. Let us do one more. evaluate 0 to pi x sin x by evaluate 0 to pi x sin x by 1 plus cos square x. Again, it is the same property, same approach. What is that? I is equal to 0 to pi x sin x by 1 plus cos square x dx. Again, put it as equation. Again, I'm using the same property. What is our property? 0 to a f of x dx, 0 to a f of a minus x dx. Is it clear? F of a minus x dx. Now, so I is equal to 0 to pi I is equal to 0 to pi minus x sine of pi minus x by 1 plus cos of pi minus x whole square dx. Your cos square x or cos x whole square both are same. And 0 to pi pi minus x sine 180 minus theta is sine theta by 1 plus cos 180 minus theta minus cos theta actually. Cos 180 minus theta minus cos theta. But because of square again it becomes plus. So this is dx. This you will put it as 2. Same. Again add 1 and 2. Add 1 and 2. I plus I is 2i. 0 to pi x sin x by 1 plus cos square x plus pi minus x sin x by 1 plus cos square x dx. Then 2i is equal to 0 to pi 1 plus cos square x. That is x sin x plus pi sin x minus x sin x dx. Where x sin x gets cancelled. Pi outside 0 to pi sin x by 1 plus cos square x dx. This is your simplified form of this 0 to pi. Is it clear? Now sin x by 1 plus cos square x. Sin x by 1 plus cos square x 0 to pi. Now put cos x is equal to t. Is it clear? So 2i is equal to pi 0 to pi, it is sin x by बार बार क्यों चले जा रहा सर ये? So what it was? 2i is equal to pi 0 to pi sin x by 1 plus cos square x dx. Now put cos x is equal to t. What I said? You have to put cos x is equal to t. Now differentiate with respect to x. Minus sin x equal to dt by dx. The dx is minus dt by sin x. Now change our limits. Upper limit x is pi. That is cos pi equal to t minus 1 equal. Next lower limit cos 0 equal to t, cos 0 is 1. So 2i equal to pi. Lower limit is 1 to minus 1. Sin x as it is 1 plus t square. This is minus dt by sin x. Okay. Now sin x gets cancelled. According to properties of definite integrals a to b f of x dx, I can write it as minus b to a f of x dx. If I change the limits, a to b limits, if I change to b to a, I get minus. Is it clear? Right. So here I am interchanging now. So that is two I is equal to pi minus 1 to 1. Now that minus is gone. 1 by 1 plus p square dt. 2i is equal to pi minus 1 to 1. Minus is gone. This minus I'm changing the limits. That minus into minus, it becomes plus. So 2i is equal to so 2i is equal to pi 1 by 1 plus t square is tan inverse t. Integration of 1 by 1 plus x square tan inverse x minus 1 to 1. So 2i is equal to pi tan inverse of 1 minus 1. Pi tan inverse 1 is pi by 4. Minus comes outside, minus into minus plus, again 1. See here, tan inverse of minus x is minus tan inverse x. The minus will come outside. So 2i equal to pi 2 pi by 4. That is nothing but 2i equal to pi square by 2, pi equal to pi square by 4. This is our final answer. Is it clear? So first apply the formula. So this part is your formula part, and this is your sum. I square is pi by 4. This is how you are going to do this. Is it clear? Tomorrow we'll continue long answers of again definite integrals. Now let us see few 2 marks of definite integrals. Same concept. Few 2 marks that will help you in doing the sums, and easily you can score also. And sometimes your like 4 mark question, 2 mark question is giving in 7 mark. Is it clear? Last time it happened. So carefully should do the things. Okay. Let us see. Zero to 3 x by under root of x square plus 16 dx. How it look like? F dash of x by root f of x is 2 root of f of x. This is a formula. But here, inside the root, I'm having x square plus 16. So you are going to multiply and divide with 2 because x square derivative is 2x. That is multiply and divide with 2 outside. 0 to 3, 2x by under root of x square plus 16 dx. Now 1 by 2. Now this looks like f dash of x. This looks like f dash of x. And this is look like f of x. So 1 by 2. 1 by 2 f dash of x by 1 by 2. This is f dash of x by f of x. Is it clear? So 2 root of x square plus 16. What are your limits? 0 to 3. Now 2 gets cancelled. Under root of 3 square plus 16 upper limit minus under root of 0 square plus 16 lower limit. 9 plus 16 minus root 16. That is root 25 minus. So the answer is 1. Is it clear? So we'll continue tomorrow. And so far what we done is circles, system of circles. The parabola long answers has been done. Hyperbola also. And indefinite integrals. Now, right now we are doing definite. Once I do definite, then we'll go for like 2 marks and 4 marks of whatever the chapters you are having. Is it clear? So that is the thing. And we'll continue tomorrow.